problem, copper rod, initial length is 100. So initial length L naught is equals to 100 meter, and this expanded region is 0.02 meter. So altogether actually 100.02 meter. So this is actually the L equals to, the final length, let's say 100.02 meter, and deal with this part actually. So this part is actually the increase of length, let's say del of L. Linear coefficient is given, and as this is copper, so let's write down at subscript copper, alpha of copper is equals to 16.7 times 10 to the power minus 6 per Kelvin. What we have to calculate? We have to calculate the temperature, the rise temperature. By using the linear expansion of coefficient, we could write down alpha is equals to del of L over L naught and change of temperature. And here, so what we have to calculate? We have to calculate the rise of temperature, right? So the rise of temperature represents del of T is equals to what? From the formula, we could write down del of T is equals to del of L over L naught times alpha. Let's plug in the value here. So del of L is equals to 0.02. L is 100 times 16.7 times 10 to the power minus 6. So we have got 11.98 degrees Celsius. So we could write down almost 12 degrees Celsius of temperature rise to expand from 100 meter to 100.02 meter. The second part of this question, compare the expansion if the same rod were aluminum heated up to 870 degrees Celsius. So here another rod which is made by aluminum, and the temperature rises up to 875 degrees Celsius, as well as determine the aluminum expansion coefficient, the length coefficient actually. So we have to determine the alpha of aluminum. So in this part, the rise of temperature, let's say del T is equals to 875 degrees Celsius, as the initial temperature, let's say it was 0 degrees Celsius, and at 0 degrees Celsius the initial length L naught was same as 100 meter, and the length expansion colored by the green, which is del of L, is equals to 0.02 meter, and to determine the linear coefficient for aluminum is equals to del of L and initial length and the change of temperature. And here the temperature is much higher than the previous rod. For aluminum it is 875 and L is 100, and this is same as the previous case O2. So we have 2.29 times 10 to the power minus 7 bar Kelvin. So for copper and the aluminium, the length was 100 for both, and the expansion is just about point, let's say 0.02 meter for both cases. And for copper the temperature was 12 degrees Celsius, and for aluminum it was 875 degrees Celsius. So what we can comment at last, that copper expands much more degree than the aluminum in case, hence the aluminum needs much higher temperature to rise, right? So this is actually the comments for the argument or the explanation for these questions. Thank you.